Okay, so let's try this number 16 again. All right, so this is the setup that we got here going, right? And so we're supposed to find, the first thing we got to do is find a relationship between A and B. This turns out to be, I don't think, that bad once you know what's going on. So we made this into into two right triangles, right? And so since this is a 45, 45, 90, if this is B, then this is what?
Cranberry cake.
B over the square root of 2, and this is also B over the square root of 2. And then this is a 30, 60, 90, and so this is the hypotenuse. So the short leg is half of that, and the long leg is the short leg times the square root of 3, okay? And so these obviously have to be equal to each other. So B over root 2 equals A root 3 over 2, yes? Yeah. And so then what do? We're trying to find B over A. So we divided both sides, multiply both sides by 2. So those cancel, and divided both sides by what? Oh, no, I did that the wrong way. I want A over B, don't I? You guys aren't being very helpful.
You want to be...
I want to multiply both sides by the square root of 2.
Girl.
So those cancel. So B is equal to square root of 6A over 2. There we go. And then I divide both sides by A. So B over A equals square root of 6 over 2, which we figured out yesterday is the same thing as the square root of 3 over the square root of 2, which they say in the problem, right? So should we just change it to that just for funsies?
But we can just do that?
Yeah, because if I take, how would I do that? I would do that by, I don't know. Yeah, rationalizing the thing. If I went square root of 2 times square root of 2, then that's square root of 6 over 2, so they're the same thing. So I guess what I'm doing there, and I don't know what the point is of doing that, but I'm rewriting the square root of 6 as the square root of 3 times the square root of 2, and I'm rewriting 2 as the square root of 2 times the square root of 2, right? And then the square root of 2's cancel, so B over A equals root 3 over 2. All right, so B over A I'm going to replace with root 3 over root 2. That equals sine of B over the sine of A. And then I'm going to rewrite this as, by cross multiplying, square root of 3 sine of A equals square root of 2 sine of B. Okay? And then I'm going to use implicit differentiation. So now we're doing A to find dB dA. And maybe I should have the square root of 2 still over here. So what's the derivative of this? Yeah, it's going to be root 3 over root 2 cosine of A, and that would be dA dA, because our independent variable is A, so I don't need to do that. And then that's going to equal the derivative of this, and the derivative of the sine of B is cosine of B dB dA, like that, right? And then to solve for dB dA, I multiply or divide both sides by the cosine of B. So those cancel. So dB dA equals root 3 cosine of A over root 2 cosine of B. So that's the answer to part A. Nice job. All right.
So do you think there's actually a job that has that
Oh yeah.
makes up stories for?
Oh, it makes up stories for him?
Yeah.
Yeah, it's called novelist.
Should be a homework something.
No, I don't think so. I don't think so.
What was it? Root 3 cosine of
I
A.
think that's stories now.
I'm going to do this. I'm not. What?
Okay.
Well, at least I'm smart now.
Can you see that movie?
B says calculate the BDA when A equals pi over 4 and B equals pi over 3. Leave your answer in exact form, so you better get out your circle charts.
Got it.
So I'm going to go cosine of pi over 4 divided by cosine of pi over 3. No. What's the cosine of pi over 4? 1 over root 2, or root 2 over 2. And what is the cosine of pi over 3? 1/2. Okay, so that comes out to be root 3 over root 2 over root 2 over 2. So what am I going to do to solve that? Flip it over and multiply. He's down, but he's not out. So 2 over root 2. So root 2 times root 2 is 2. And that'll cancel with the 2 on the top. And so my final answer is square root of 3, right? Okay, so that means we are back into the, now it says write the linear approximation of f at a equals pi over 4. So we're doing that same thing again, where our equation would be y, which is really b, right? Right? Isn't that b, the y, yeah, dy dx, and the b is on top, okay. So b minus the,
Cosine.
no, the y coordinate, or the b coordinate at that point. In other words, what did we plug in for b? Pi over 3. So b minus pi over 3 equals the slope, which we just figured out is square root of 3 times x, which is a, minus the x coordinate, which is, or the a coordinate, which is pi over 4. Okay? So a minus pi over 4 plus, I'm going to swing that, pi over, yeah, that's pi over 3 over there, so it's going to be b equals root 3 times a minus pi over 4 plus pi over 3. Maybe I left that root 3 off there or something. But I like what we got going there. Okay, d using c when a is 46, b is approximately how many degrees? Answer either exactly or 3 decimal places. So I'm going to put 46 degrees in for a. So b equals root 3 times 46 degrees minus, and now since we're degrees again, how many degrees is pi over 4? How many degrees is pi over 4? Oh, you know that, it's halfway in between, so it's 45. Okay, plus how many degrees is pi over 3? That's a third of the way from 60. Okay, so my exact answer would be, if I subtract those, I'm going to get 1 degree times root 3, so it's going to be 60 degrees plus a root 3 degree. Or you could do that as a decimal. Okay, so 60 plus root 3 degrees. Okay?
Take the derivative.
So we're done with that? Oh, yeah, this was D. This is C. Okay.
That one needs to be.
Okay, so I don't know, are you kind of understanding a little bit more better the, not why you would do it, but the idea of the tangent line approximation? So you basically are coming up with the equation for the tangent line at a particular point, and then plugging in the value of the point close to that to estimate what the...
That seems silly.
It does, because you're plugging it into the equation for the tangent line instead of the equation for the function. Why not just plug it into the original function? I do not know. Okay, so last one, x cubed plus 4x squared equals 8y squared, comes out with a graph like that. Part A, there are 2 points on the graph whose x coordinate is 4.
Yes, there is.
Can you see them?
No.
You go to 1, 2, 3, 4, and went straight up or straight down to the graph, and you would see those 2 points. So one's going to be positive, one's going to be negative, and it looks like they're going to be the same thing. So opposite sides. Let P be the one with the positive y coordinate, and Q be the one with the negative y coordinate. I know the x coordinates.
You do?
They're 4. Find P and Q. So how do I find the y coordinates? No. Plug in 4. Here's my original equation. So 4q plus 4 times 4 squared equals 8 times y squared. So 4 cubed is 64, yes? And so 64 plus 64 is 128.
That is.
Divide both sides by 8. Does 8 go in there evenly?
Yeah.
Yeah, 16 times. Okay, so y squared equals 16, so y equals
That's silly.
plus or minus 4. So P
That's a lot
was
of
the
fours.
positive one and
Where did it go?
That's under my desk. So P was the positive one and Q was the negative one, right?
Yep.
Okay, B, the implicit derivative is, so the derivative of x cubed is,
3x squared.
okay, the derivative of 4x squared is 8x. And the derivative, okay, we got that figured out. So I need to solve this for dy dx, right?
Yeah.
So that's pretty easy. Divide by both sides by 16y. So dy dx equals, I'm just going to leave it as 3x squared plus 8x over 16y. Okay? We got that?
Where are we taking our final?
Your final will be on Monday, June 4th.
No, will it really?
Huh?
Monday, June 4th.
We need to come in and have a study session in here that weekend. I did it last year, we'll do it this year.
When breakfast?
Breakfast would be the 5th.
Yeah.
Where's that Tuesday?
Tuesday.
Colin Parker.
Yeah, is he in town? No, call him.
No,
It would be the honorable first guest cook at the calculus breakfast. He makes a mean omelet.
I want to try.
A mean omelet, not a nice omelet.
No, not a nice omelet. Okay, so the derivative is 3x squared plus 8x over 16y. 3x squared plus 8x over 16y. And we have the point 4, 4, and we have the point 4, negative 4. Okay, so half of you over here-ish plus Nico can choose your free, oh no, Nico, you put this group over here. You guys plug in 4 and 4 and see what you get. Perfect. You 4 over here, plug in 4 and negative 4 and see what you get. So C is P, slope at P equals, and D is the slope at Q equals. Okay, what's the slope at P?
Copperville.
1 point, no, at P, you had Q. Oh, you did both. Did you guys get 1.25 also?
Yeah.
Sweet deal. Hi, Nico. What's the slope at Q?
-1.
What a surprise. All right, E, is there a tangent line to the curve at the point -4, 0? Don't even have to plug anything in. Look at the derivative and tell me the answer.
No.
No. Because if I put 0 in there for y, then it's going to be undefined. So that would be no. Like that one. F, is there a tangent line at the point of the curve 0, 0?
F, no. Get it?
You're suspended. And you can kind of see what's going on there at the graph. On the graph, if you look at those 2 points, I guess I have your little packet.
I know.
At -4, 0, the tangent line would be straight up and down, would be a vertical tangent, which you can't have. And then at this one here, since the graph intersects itself there, how would you know which tangent line to use? Okay.
Yes.
Okay, this seems like a totally different question. Maybe it is. Oh yeah, that was supposed to be blue. It was supposed to be an 18, not a G. Oh no, we have to do 3 questions today.
Really, we only had to do 2, but you know, I didn't.
Well, I did a bad job on
Kayla
that
says
one.
it's the same problem.
Because then it says, will be the same as the graph will be.
Oh,
Got you.
you got me. All right, so that really is G. Okay, nice job, Kayla. I don't know what I would do without you next year. I guess just make mistakes and normal comments.
Are you doing your dub testing?
No.
Are you doing AP testing?
Yeah, we'll just go back to AP. He said most people just do AP.
How many people signed up? You know,
No, I
72.
don't care about any of that stuff.
I told you there's no strong.
Yeah, I don't want to know what classes I'm teaching until I come back to work in August. I don't want to think about that. I'm not one of those guys that's down there checking my schedule and figuring out these are my classes and oh, that person shouldn't be there. They're not smart enough. Figure it out later. The location PT equals blah, 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 so it's the same thing. Okay, so define the function s of t equals y prime of t over x prime of t. Okay, let's do that. It's defined. Should we figure out what it is?
Sure.
Okay, so let's take the derivative of, yeah, we need to. First thing is K, calculate s of t. So we need to figure out the derivative of both of those. So how do you want to do that? Distribute the 1. Why is the 1 even there?
I think she might have thought of
Why are you even there?
Why is this one right here?
it. Because you put it, she's trying to say something. No one's.
Kayla?
I felt like this makes 2.
Okay, but I'm just wondering, this 1 is like totally unnecessary, isn't it? So this equation is really t minus 2 cubed, and then Kayla says distribute the negative 2. So minus 2t plus 4. Okay? And so if I want to take the derivative of that, for this I take and put the exponent in front, right? Subtract 1 from the exponent, and then multiply it by the derivative of the stuff inside, which is just 1, so who cares? Minus 2.
Dang it, I was paying attention.
Okay? So that's y prime.
I don't write.
Now x prime is going to be a little bit of a problem because this 2 is going to impact the thing, but let's distribute that anyway. So let's rewrite x of t as 2 times t minus 2 squared minus 4. How's that sound? And I guess that derivative doesn't come out to be too bad. Put the 2 in front makes it 4 times t minus 2 to the first. Derivative of the stuff inside is just 1. Derivative of negative 4 is example. So this is 4t minus 2. And then we'll simplify this one. Oh, we can't simplify. I'm going to cancel this and this, but I can't do that. So we'll leave it just like that. Okay? Okay, so B, figure out P of 0. What is P?
P is xt comma y.
Okay, so that means I have to figure out what x of 0 is. So if I plug 0 into here, what do you get?
I would get 4.
4. If I plug 0 into this, what do I get? this would be
Wait, what are we plugging in?
plugging in
Zero.
0. I don't like that one.
Oh, so that'll be -4.
So this would be -8. That's going to be 0 plus 4, so it's -4. Okay, so that means that P of 0 is 4, -4. Is that a point on the graph?
Yeah.
Well, that's one of the points we found before, huh? Okay, and then what is S of 0? So now I have to plug 0 into this derivative here. If I plug 0 in here, -2 squared is 4, times 3 is 12, 12 minus 2 is 10, over -2 times 4 is -8, so 10 over -8 is -5/4. Okay? Why do we care? Okay, so yeah, C and D is just simple algebra. You're just plugging things in there, and it's 2 minus √2, so the 2's will cancel, and then you can square the square root of 2, and good things will happen in your life, but there's no reason for me to have to do that with you guys, so you can do that on your own. So we made it.
Good job, Vic.
Okay. All right, so I will print up week 8 for you right now, and you
Print up
can,
what?
I'll print up week 8 for you right now.